In this section, we want to learn about how to graph polar equations. We will follow the general process. Firstly, we will graph y equals f of x in rectangular coordinate system after you write r as y and theta as x. Then we will graph the given polar equation in polar coordinate system. We have to interpret the graph we drew in rectangular coordinate system by regarding x value as an angle in standard position and y value as oriented distance between the pole and the point. Let's do an example. We want to sketch a graph of the polar equation r equals 4 minus 4 cosine of theta. To do that, we want to graph y equals 4 minus 4 cosine of x first. We got this equation by replacing r by y, theta by x. To graph this, let's analyze the function. The given function can be written as y equals minus 4 cosine of x plus 4. This 4 is added to the function y equals minus 4 cosine of x. So there is a vertical shift up 4 units. Because of 4 multiplied to the cosine function, there is a vertical stretch. This minus indicates there is a vertical reflection. By looking at this, we know that the period is 2 pi, the same as the original cosine function because there is no number in front of x. This vertical stretch determines the amplitude. Amplitude is 4. Let's consider the maximum and minimum value of y equals minus 4 cosine of x plus 4. Before we do that, let's consider the maximum and minimum of y equals minus 4 cosine of x. The maximum is 4 and the minimum is minus 4. Based on this, we will determine the maximum and minimum of y equals minus 4 cosine of x plus 4. We will use the vertical shift up for unit. So to get maximum, we have to add 4 to the maximum of y equals minus 4 cosine of x, so we get 8. Similarly, we get the minimum value 0 by adding 4 to minus 4. When we combine all those information, we will get this graph. What we know is the maximum value of the graph must be 8 and the minimum value of the graph must be 0. So this line is maximum and this line is minimum. There was vertical shift up for unit, so x-axis in the graph of y equals minus 4 cosine of x will shift up to y equals 4 here. There was a vertical reflection, and this is a cosine function. So instead of starting the graph at the maximum value, we have to start the graph at the minimum value. And then we will draw the wave function. Then we will label the important point. And this coordinate is 0 and 0. The meaning of that is when angle is 0, the distance between the origin and the point is 0. So that becomes a pole when we graph the polar equation. And this means when angle is pi over 2, the distance between the origin and the point on the terminal side of the angle pi over 2 will be 4. We will keep interpreting in that way to graph the polar coordinate. Let's do that. To graph the polar equation r equals 4 minus 4 cosine of theta, I embedded the polar coordinate in the rectangular coordinate system. The positive x-axis is a polar axis. What I labeled as benchmarks are rectangular coordinate, and these are the angles. At the starting point, it starts with 0 and 0. When the angle is 0, the distance is 0. That means that point must be a pole. And when angle varies between 0 and pi over 2, meaning we think about these angles, angle becomes larger and larger until it becomes pi over 2. The distance also increases until it becomes 4. So we start the distance 0, but when we follow this angle direction, we end up having the distance 4 when the angle is pi over 2. The only way that can happen will be when that changes in this way. When angle varies from pi over 2 to pi, the distance will increase from 4 to 8. So we are thinking about angles between pi over 2 to pi, and we follow this direction because angle increases. The distance was 4, and that in the end it should be 8 here. So the points will vary along this curve. When angle is between pi to 3 pi over 2, we follow these angles and we go this direction because angle increases. But when angle increases, the distance between the origin and those angles will decrease to 4. So when the angle is 3 pi over 2, we end up being here, and we go this direction. And when angle is in between 3 pi over 2 to 2 pi, we will follow these angles counterclockwise. The distance at the angle 3 pi over 2 is 4, and the distance will decrease until it becomes 0. So the shape will look like this. If you go further, then you will follow this curve again and again. So this is the completed graph. The equation is called cardioid. Here is the general equation of the cardioid. This is the example of horizontal cardioid. General equation is R equals A plus or minus A cosine of theta. And equation of a vertical cardioid is R equals A plus or minus A sine of theta. In cardioid, those are the same numbers. In the previous example, we learned about how to graph the horizontal cardioid. You can practice with this problem. This is a vertical cardioid. Because we use sine function, I will give you some hints. What we have to do first will be graphing y equals 4 minus 4 sine of x. If you graph that, then you will obtain this graph because the maximum value is 8 and minimum value is 0 and period is 2 pi. There is a vertical reflection there. You can analyze the graph by using the same method we did with y equals 4 minus 4 cosine of x. After that, you will graph the polar equation. To do that, we embed the polar coordinate in the rectangular coordinate system. And then we have to interpret this graph. This graph starts at 0 and 4. When the angle value is 0, the function value is 4, so the distance will be 4. Angle value is 0, the distance from the origin will be 4, so we start from here. And then when angle varies between 0 and pi over 2, the distance will decrease and eventually become 0. So we travel this way and then we keep interpreting the graph here, and then we will get the vertical cardioid. You will fill out all the details so that you make sure that you understood everything clearly.